Hello friends, welcome to the Zeta Online Science Academy. Today we are going to discuss about first chapter of O-Level series 5070 according to the syllabus 2023, 24 and 25. If you are new at our channel, then kindly subscribe our channel and press the bell icon so that you can get the notification of every video. I want to advise you, please don't miss a single video if you want to complete understanding and good grades in O level. We will also discuss question answers during the lecture. So let's start the video. First, I will write the course content and then I will explain it. States of matter. What is matter? Anything that have mass and occupy space is said to be matter. All the things around us are examples of matter. The water we drink is example of matter. The air we breathe is an example of matter. The food we eat is an example of matter. Our house is made up of certain materials. These materials are matters. So this is our syllabus. State distinguished properties of solids, liquids, and gases. Before I discuss these properties, I will discuss about the structure of solids, liquids, and gases. The course content they provided us describes structure of solids, liquids, and gases in terms of particle separation, arrangement, and their motion. This type of the questions comes in P2, in paper number 2 of your exam mostly. So understand it and listen it carefully. Solids. If we see the structure of solids, there the particles of solids are closely packed. As you see in this diagram, their particles are very closely packed. These particles are closely packed. They have low interparticle distance. This is one particle and this is second particle. The interparticle distance is very low. This is, if I show it with a different color, this is only interparticle distance in solids. These particles are connected with each other by strong cohesive forces. What is meant by cohesive forces? The forces which are present between same particles. Same particles are said to be cohesive forces. In liquids, the particles are loosely packed as compared to the solids. The particles are loosely packed. You can see that they have some interparticle distance. Therefore, they can move freely. I said they have more moderate interparticle distance and they move freely. While in gases, they have large interparticle distance. Therefore, they don't have ordered structure and they have significant gaps among them. They are widely separated. This is separation. While if we talk about arrangement, the solid particles are highly ordered and structured. Therefore, they form a certain lattices. We can see, we can also call them crystal lattices. Crystal is another name of a solid. Crystal lattices. They form For example, cubic, tetragonal, hexagonal, etc. If I talk about liquids, liquids are less ordered and they don't have fixed pattern or lattice. If I talk about gases, gases has no organized arrangement. They are highly disordered structures. Motion, the motion as the particles of solids are very close together. They are closely packed. They have strong cohesive forces. Therefore, they cannot leave their position. They are fixed at their position. As they cannot leave their position, it means that they don't have translational or rotational motion because they are fixed at their place. Because they are fixed at their place. Therefore, why? They can vibrate at their position. They can vibrate. Therefore, we can say that they have only vibrational motion. While the particles of liquids have certain gaps, therefore they can move here and there. Therefore, they have translational, rotational, and also vibrational motion. Three kinds of motion are present in liquids. If we talk about gases, gases have certain inter and wide interparticle distance. Therefore, they also have translational, vibrational, and rotational motion with high velocities. Due to this high velocities, they collide with each other and they exert great pressure. Now I will come towards our first thing that I skipped earlier, that is distinguish properties of solids, liquids, and gases. As you know about the structure of solids, liquids, and gases, now it will be easy to distinguish and understand the properties of solid, liquids, and gases. If we talk about the shape of solids, solids have definite shape. As we talked earlier, they form different lattices like cubic, tetragonal, octagonal, tetrahedral, tetragonal, square, bipyramidal. While liquids, they take the shape of container because they are less ordered and they have no arrangement. If a liquid is present in glass and we pour this liquid in a jug or any other utensils, then you can see this water has adopted the shape of jug from glass to jug. Therefore, they take the shape of container in which they are enclosed. Similarly, gases also take the shape of container because they don't have ordered structure. They don't have ordered structure. Just a moment. They don't have ordered structure. If I talk about volume, what is meant by volume? Volume means space they occupy. Space they occupy is said to be a volume. As solids have ordered structure, their particles are very close to each other. Therefore, they have definite volume. Their volume are certain. We cannot change their volume. Similarly, liquids also have definite volume. They will occupy the same space, either they are in glass, jug, or any other utensils or container. While gases, don't have definite volume because their particles are very far from each other. Therefore, and they are moving with large velocities. Therefore, they spread out. And if they spread out, they can occupy more volume. For example, a gas is enclosed in this volume. Their particles are present here. If we enclose this gas in this container, which is highly big, then you can see that gas will occupy this container. It means they have no definite volume. Their volume can be changed. Now we come to the density. Therefore, at this time we are comparing solids, liquids, and gases. As you know that solids have compact arrangement of particles. Therefore, they occupy less space. If they occupy less space, it means that they have less volume. Their volume is less. If they have less volume, their density will be high, because density is equal to mass over volume. The amount of solid is same, while their volume is very low. Due to this reason, they have very high density. While liquids, because their particles are far as compared to the solids, therefore they have somewhat high volume. If they have high volume, then their density will be low as compared to the solids, but their density will be high as compared to the gases. While gases have large interparticle distance, their particles are very far from each other. Therefore, their density will be low because of high volume. If we talk about compressibility, same thing applies here, because particles of solids are very close to each other. They don't have space in between them. Therefore, we cannot compress them. They have very little compressibility. If we exert a pressure on them, they break, they change their shape. Their compressibility is very low. While liquids have medium compressibility, because some space is present in between the liquids. While gases have very high compressibility, because a lot of large space is present in between them. Ease of flow. Gases do not flow because the strong cohesive forces are holding them, while liquids flow easily because of distance between them. They can be moved from here and there. And gases also flow. Due to this reason, liquids and gases are also known as fluids, because they can flow. If I talk about intermolecular forces, in solid the intermolecular forces will be very strong, while in liquids the intermolecular forces will be moderate, while in gases the intermolecular forces will be low. What is meant by intermolecular forces? The forces that are present between molecules. For example, this is molecule of hydrogen. This is H2O. This is intramolecular forces, which form a molecule, while these forces which are represented in dotted line are intermolecular forces. These are present in between complete molecules. Intermolecular forces. I hope this will be clear for all of you. Now we will move towards our next content. If you have any query regarding this, you can easily ask in comment section. I will answer to you. Next content is describe and explain changes of state, melting, boiling, evaporating, freezing, and condensing in terms of kinetic particular or kinetic particle theory. According to the postulates of kinetic theory, what is meant by kinetic? Kinetic is a Greek word which means moving. This theory says that the particle in a substance, rather a substance is solid, liquid, or gas, their particles are in constant motion. It means that their particles are moving. Therefore, because they are moving due to motion, they possess kinetic energy. This is the main postulate of kinetic particle theory. The second postulate of kinetic particle theory is that on the basis of which we will explain melting point, boiling, evaporating, freezing, and the phenomena of condensing. What is this postulate? This postulate says that kinetic energy is directly proportional to the temperature. Kinetic energy is directly proportional to the temperature. It means that if we increase the temperature, the kinetic energy will also increase. By increasing kinetic energy, the motion of molecules will also be increased. If motion of molecule increase, they can be moved from one place to another. It means that if they are moving with high velocities, by gaining energy, they can change their state. It means that they can be converted from, for example, I can elaborate. This is a solid. Their particles are very compact, are in very compact arrangement. If we give them heat in the form of energy, in the form of temperature, we are increasing temperature, their molecules will start moving, because according to this postulate, the kinetic energy is proportional to temperature. We are increasing temperature, kinetic energy will also increase. And if kinetic energy increase, their particles will be far from them, and this state will become liquid state. And this phenomena in which a solid is converted into liquid is called melting. In which a solid is converted into a liquid is called melting. If a liquid is converted into a solid, this phenomena is called freezing. I am repeating again. If a solid is converted into liquid, solid converted into liquid, this is called melting. And if a liquid is converting into a solid, this phenomena will called freezing. How liquid will convert into a solid? A liquid can be converted into a solid by decreasing temperature, by keeping the liquid in cool place. it can be converted. We can see that water is converted into ice in refrigerator, and ice is converted back into water, also water. This is melting. Now I will introduce a different term, the temperature at which solid is converted into liquid is called its melting point, because at this temperature the solid starts melting. This is the conversion of liquids and solids. Now if we talk about conversion of liquids into gas, if a liquid is converted into a gas, this will be called evaporation or boiling. We will explain the difference of evaporation and boiling later, but at this moment we are only discussing liquid is converted into gas. How can liquid can be converted into a gas? By increasing temperature. If we increase the temperature, the kinetic energy of the particles will be increased and it will be converted into a different state, will be a gas. If a gas is converted into liquid, this will call the process of condensation. In this diagram, in this graph, you can see that gas, liquid is converting into gas. It is called evaporation or boiling. While gas is converting back into liquid, this process is called condensation. Although these terms are not included in our syllabus, but we will also discuss them briefly. If a solid is directly converted into gas, this phenomena is called sublimation. While we can see that a solid is usually firstly converted into liquid, then a liquid is converted into gas. We can take the example of water. Ice can be converted into water and then into steam. But if a solid is directly converted into a gas, then this process will called sublimation. And similarly, the reverse of it, a gas can be converted into a solid directly, and this process is called deposition. We apply this phenomena for the preparation of nanoparticles. You will learn about nanoparticles in higher classes. I said evaporation, if I summarize them, evaporation is reverse of condensation. Melting is reverse of freezing. Sublimation is reverse of deposition. When a liquid is converted into a gas at certain temperature, this temperature is called boiling point. Same as when solid converted into liquid, this is called melting point. When a liquid converts into a gas, this point is called, temperature is called freezing temperature. Now, what is the difference between What is the difference between evaporation and boiling? One thing is common in these two processes, in evaporation and in boiling. In both processes, liquid is converted into gas in both processes. Then what is difference between evaporation and boiling? So the first difference is evaporation only occur at the surface of liquid. Evaporation only occur at the surface of liquid. This is a liquid. Some particles with high kinetic energy leave the surface of liquid. This phenomena is called evaporation. While boiling, it occurs throughout the volume of liquid. It does not only occur at the surface of liquid. If we it during boiling, a liquid form bubbles. This this arrangement is just like solid, but you can consider it liquid. I am just making a roughing diagrams. You know that I am not good at drawing. It occurs in the entire volume of the liquid. The second, evaporation occurs at any temperature, while boiling occur only a certain temperature that is called boiling point. The evaporation take energy from surrounding. That's why evaporation causes cooling. Evaporation is a cooling phenomena because it takes energy from the surrounding. How? This is a liquid, the particle with high kinetic energy leave the surface of liquid. Therefore the energy of this system decreases, and energy from surrounding move into the system. That's why the temperature of surrounding decreases and cooling produced. While boiling needs sustained and continuous source of energy. If you are boiling a water at 100 degrees centigrade and suddenly you decrease your temperature at 78 degrees centigrade or 80 degrees centigrade, the boiling will be stopped because it needs sustained and continuous source of energy. Evaporation is a very slow process. It can be increased with temperature, while boiling is a rapid process. Now I am giving you a beautiful trick so that you can solve the questions in exams very easily. This is mind trick, so you can call this trick as Yusuf Abdullah trick. Therefore, I named this trick is YA trick. Yusuf Abdullah. Yusuf Abdullah is my name. Oh, I wrote it very bad way. Yusuf Abdullah trick. Now, what is this trick? Any substance, this will help you in answering both in P1 exams and also in P2. We will discuss these things. Any substance whose melting and boiling point is above room temperature, it will exist as solid. Any substance. What is room temperature? It is 25 degrees centigrade. For example, if we see iron, its melting point is 1535, while its boiling point is 3000. This substance is solid. You can see that their melting point and both boiling point are above room temperature. Similarly, if you see carbon, their melting point and boiling point is very high. They are above than room temperature. It will also called a solid. This is melting point of a solid. And this is boiling point of a solid. If I ask from you, at 1000 degree centigrade, what will be physical state of iron? What will be your answer? You can pause the video and answer it. Take a little time. At this temperature, a solid is melting. It means that it is converting into a liquid. Now this is liquid, and at their boiling point is 3000. It means that at 3000 temperature, a liquid is converting into gas. Liquid is converting into gas. So at 1000 degrees centigrade, the iron will exist in liquid state. I hope I become able to clear your concepts. Now, this for solid. If we talk about liquids, any substance whose melting point is below room temperature, and boiling point above room temperature will exist as liquid. You can see the example of alcohol. Alcohol is a liquid. Its melting point is -117. This is below room temperature, while its boiling point is above room temperature. Therefore, this is liquid. While water, its boiling point is 0 degree centigrade. This is lower than room temperature, and boiling point is higher than room temperature. This water will also exist as a liquid. One additional information I will provide you. Water has same freezing and melting point, that is 0 degree centigrade. That's why ice, you can find ice and water in the same container. Okay. If I ask what will be the physical state of water at 200 degrees centigrade? Physical state of water at 200 degrees centigrade, your answer should be a gas, because at this temperature the liquid starts converting into a gas. And the third one trick is, if any substance whose melting and boiling point is below the room temperature will exist as a gas. Any substance whose melting and boiling point is below room temperature will exist as a gas. You can remember why a trick and solve the question very easily. Nitrogen is, the melting point of nitrogen is -210 and -218. These both are below the room temperature. Similarly, their boiling points are also below the room temperature. The room temperature is 25 degrees centigrade. Therefore, these both two substances are gases. Now, surprise me and answer the question correctly. What will be the physical state of nitrogen at -2 degrees centigrade. You can pause the video and think and answer the question. The answer is at liquid state. In liquid state, because its melting point is -210, -210 degrees centigrade. It means that at this range, between -196 and in between -210, the substance will exist in liquid state. Yes. Before moving into the next topic, I think we need some practice. We should see some papers that are appeared in exam so that you become some kind of satisfied. Let's some practice. Then we will move towards heating and boiling and cooling down, and this will be end of today's lecture. These MCQs are part of your paper in P1 exam. The first question is, change of state occur between solids, liquid, and gases. This is a gas is converted into a liquid and a liquid is converted into a solid. Now you can memorize and answer the question. What changes occur at P, Q, R, and S? Think about that. You can also pause the video. Just a minute. A gas is converted into a liquid. When a gas is converted into a liquid, what is this process? Gas, that is ordered structure, is converted into an ordered structure. This phenomena is called condensation. Condensation. It means that at point P, the condensation is occurring. You can see there is only one option in which the P indicating is condensation. You can also take that this option is correct very easily. But we will also tell you other option so that the correct option is a condensation. Okay. And at point Q, what is happening? Liquid is converted into a solid. Liquid is converting into a solid. What is this called? When a liquid is converting to a solid, this phenomena is called freezing. You can see that this process is called freezing. And when a solid is converting back into a liquid, this phenomena is called melting. You can see that melting. When a liquid is converting back into a gas, this is called boiling. You can see that this is boiling. By only clicking on this point, you can answer your question very easily. So don't stuff your head in useless things. Okay. Now we can see, and oh, sorry. Another question is this: which row correctly describe changes in a particle when a substance freezes? What it means that when a substance freezes? It means that a liquid is converting into a solid. What he is asking? Arrangement of particles and the energy change in particles. When a liquid is converting into a solid, it means that there is arrangement of particles, a less ordered structure. Liquid is less ordered, is converting into an ordered structure. So If you see arrangement of particles becomes more ordered. This point also contains particles become more ordered. This point says that particles become less ordered. This is wrong option. This is also saying particles become less ordered. This is also wrong option. So we have to choose in between these two options. Second, energy change in particles. You also know that when a liquid is converting into a solid, I said that this will occur when we decrease temperature. When temperature is decreasing, it means that particles are losing energy. Therefore, their temperature decreases, their motion stops, their kinetic energy decreases, and they converted into a solid state, a more ordered structure. The particles will lose energy. So the correct option will be second. If we move into another MCQ, which statement about states of matter is correct? When a liquid freezes, it becomes a solid. This is correct, and energy is released to the sun. This option is seeming correct, but we can also tell the other option. When a liquid reaches its boiling point, it becomes a gas. ये gas बन जाता है. This process is called no. This process is not called evaporation. This process is called boiling. I explained you difference between evaporation and boiling. So this is wrong option. When a solid changes directly into a gas, this process is called condensation. No, this process is called sublimation. When a solid melts, the particles get further apart and have less energy. No, the particles have more energy. Therefore, they become disordered. Their temperature is increasing, then their kinetic energy is also increasing. When kinetic energy increases, on ordered structure is converted into a less ordered structure. So this option is also wrong. So the correct option is the first one. Let's move forward. Now we will solve some questions from also paper 2 so that you don't confuse during the exam. They draw a dot cross diagram to show arrangement of electron and carbon dioxide. We will not study it yet, and we will explain it further. So we can explain it also. Describe the motion and separation of particles in a gas. No, carbon dioxide is a gas. I explained you earlier what is motion. At gaseous state, the particles move freely. They have translational, vibrational, and rotational motion. Rotational and vibrational motion. And separation, the particles are widely separated. Particles are widely separated. So I hope this question was very easy for you after seeing the lecture thoroughly. The second question is, bromine is a liquid at room temperature. Bromine liquid at room temperature. Describe the arrangement and separation of their particles in a liquid. Arrangement, their particles are close but have some distance, have interparticle distance. Therefore, they can move freely. What is about separation? Their particles are far from each other. I explained these points during the lecture. We studied here. Now moves forward. This is now. This table shows some information about elements in group 5 What is group 5? We will study about further. No, we have only concern with melting point and boiling point that we studied now. Says that nitrogen, phosphorus, arsenic, antimoney, bismuth. Get this electronic configuration for phosphorus. We will study it later. The second question he is answering, he is asking, sorry, not answering. We have to answer that question. Is why it is easier to predict the boiling point of bismuth than to predict its melting point. Now, my dear fellows, my dear friends, you can see that solids have very ordered structure. If they are very ordered structure, it means that they have their crystal lattice. We will study in later chapter that crystal lattice has specific shapes. It can be cube, it can be tetragonal, it can be tetrahedral, it can be hexagonal, it can be octahedral. They have certain faces, they have certain angles. Therefore, it is difficult to predict the melting point. It is easy to predict the boiling point because of its structure. Because at when the substance is at liquid state, it doesn't have any particular shape. No particular shape. Therefore, it is easy to predict boiling point than melting point. कहते हैं use information from the table to explain why antimony is liquid at 1000 degrees centigrade. Here antimony lies, you can see that 630 degrees centigrade is its melting point. Is its melting point, while its boiling point is 1380. I asked you this question again and again. At this temperature, it starts melting. It means that it is converting into a liquid. And before boiling temperature, it exists in liquid state. That's why कहते हैं why liquid state, because its boiling point is higher, 1380 degrees centigrade. They have less kinetic energy. Therefore, it will exist as a liquid state. I hope this is clear. Now move further. This is the last question. The table shows information about elements in group 6. We have don't concern at this time with group 6. We just concerned with melting point and no boiling point and not density is there. We also study about density later. Use electronic configuration. No, we will discuss it later. Predict the density of polonium. You can see that density is increasing in the group. It means that the density of polonium will be higher than 6.3 and lower than 9.4 or 7 something else. We will explain it later. The sulfur has a boiling point 440 degrees centigrade. Explain the physical state of sulfur at 200 degrees centigrade. You can see the melting point of sulfur. The melting point of sulfur is 130 degrees centigrade. And its boiling point is 440 degrees centigrade. At this point, the substance will exist as a liquid state because its boiling point is higher. I asked this question also during the lecture. This is your physical state and explanation because its boiling point is higher than 200 degrees centigrade. I hope this is clear. Now we can move into our next topic, which is heating curve and cooling curve. This is very easy topic if you understand it. If you don't understand it, it will become difficult for you. This is newly included topic in O-level syllabus. So you don't have also any past question papers, but we will practice this also. What is meant by heating curve? A heating curve shows how a substance is converted into a liquid into a gas. It means it a series. A substance is converting from solid into a liquid and then from liquid to a gas. This is sequence. This curve shows. Therefore, this curve is called heating curve because at this point we are providing heat. We are providing heat and studying the state of a substance. Interpret and explain heating cooling in terms of kinetic particle theory. We will also explain it by using the information of kinetic particle. At this point in curve, at this point, sorry, it's causing trouble. It's creating trouble again, but we will fix it. At this point, a substance will exist as solid. Here is time is increasing in this way, and temperature is increasing in this way. It means that temperature is increasing and time is also increasing. Temperature is increasing. When it means that we are providing heat. When we are providing heat, it means that a substance is becoming less ordered. After a certain time, it starts converting into a liquid. A solid is starts converting into a liquid. You can say that, you can see that now at this temperature, at this curve, the curve BC, a substance, the temperature is not increasing. Why? While we are providing heat, temperature is not increasing. The temperature is not increasing because the heat we are giving, the heat, listen carefully, the heat we are giving is used to break intermolecular forces, between solids. Therefore, when a substance is completely, when a solid is completely converted into a liquid, then the temperature curve will rise, because at melting point the temperature becomes constant. This is very this is very this is very important to understand. Very important to understand. At this point, because solid starts melting, this point is called melting point. And this flat curve where temperature is not increasing will indicate boiling point. In the exam, he can give you a curve and can ask, here will be temperature mentioned minus 10 degrees centigrade, minus 100 degrees centigrade. Can ask what is using this curve information. Answer the question, what is melting point of a substance at minus 10 degrees centigrade. So you can answering the question by seeing first flat curve. Now a substance is liquid. Now we are heating it again. We are providing temperature. At a certain temperature, it starts boiling. Therefore, at this point, this is called boiling point. At this point, at segment AB, the substance is only solid, while at segment BC, solid and liquid both exist in equilibrium, because solid is converting into gas. So solid is converting into liquid. Some solid is present, some liquid is also present, because it's converting at this point. While at CD, this is only a liquid. While at boiling curve, this is called boiling curve, both liquid and gases will present, because liquid is converted into gas, and this is a gas curve. By using this understanding, you can answer the questions. Now move towards the cooling curve. I hope this is now understandable. If you have any query, feel free easy to ask in comments. Cooling curve. Cooling curve. What is meant by cooling curve? In heating curve, we were providing heat. Were increasing the temperature. Here we are decreasing the temperature. It means that the inverse phenomena will occur. Therefore, this curve is starting from here instead of here. At this point, the substance is existing as gas. The heating curve starts from solid, while cooling curve start from gas. Please keep it in your mind. This is a gas. A gas is converting into at this point. At this point, the gas will converting into a liquid. It means that as temperature, the substance will start condensing, and at this point, both liquid and gas will exist. This is curve ED. While we are moving downward, we are seeing that this is liquid at certain point, because we are decreasing temperature, a liquid is converting into a solid. At this point, both liquid and solid will exist. When we move lower the curve, then this liquid is now completely converted into a solid. At this point, only solid will exist. This is heating and cooling. Now we will we will see some question answer related to this topic so that you can understand it easily. That will become easy for you. This is some quiz. कहते temperature is constant during a change of state. This statement is true or false. It means that a state is changing. It means that a liquid is changing into a gas. A solid is changing into a liquid. Does temperature remains constant? Is this statement true or false? Now think, move towards the lecture. You can see these flat curves. These I will make it spotlight. You can see this curve. You can see this curve. This is state. It means the temperature is not increasing. Therefore, this statement is correct, that temperature is constant during change of a state. Temperature is constant during change of a state. This statement is कहते use the heating curve below for answering question from 2 to Z. 2 to 7, sorry, 2 to Z not. It seems that I am also tired, but don't get tired. Okay. Now you can see that this is a heating curve. He gave you this information. Before answering the question, we can also write on this curve. At this point, the substance will be a solid. At this point, it will start melting. This is melting point. At this point, it will be a liquid. At this point, it will start boiling. At this point, it will be a gas. Now we answer the question. Now we will answer the Now we will answer the question. What is first question? I will remove the some zoom. Where is option of zoom? Give me a end zone. कहते ड्यूरिंग व्हाट इंटरवल इज द सब्सटेंस वेपोराइजिंग, वो कहते किस इंटरवल के दौरान जो हमारा सब्सटेंस है वो वेपोराइज हो रहा है. इट मींस इट्स कन्वर्टिंग इनटू अ लिक्विड. दिस इज D, this is E. At this point the substance is converting into a liquid. It means that it is vaporizing during the curve DE. Now move next. What letter represent a solid liquid equilibrium state? When a substance exists as both solid and liquid, you can see when a solid is converting into a liquid, when a solid is converting into a liquid, the substance will exist both in solid and liquid state. It means that it will be a flat curve. Now only there will be two flat curves. First will be AB and the second one will be BC. So this will be the correct answer. You can see here, this is BC curve BC. At this point the substance is converting. Okay. Now what is melting point of the substance? What is melting point of the substance? You can see that the substance starts melting at temperature 20 degrees centigrade and temperature remain constant until all the solid gets converted into a liquid. It means that the melting point of the substance is 20 degrees centigrade. Melting point of the substance is 20 degrees centigrade. What is the boiling point of the substance? This flat curve DE will show the melting. It is in between 80 and 100. It is in between 80 and 100. You can see that. So we will see the option and we will answer the question. This type of question will come into your exam hopefully. And if you understand that, you can answer it easily. You can write the boiling point 85 or 90 because they are no degree 85 degrees centigrade or 90 degrees centigrade. How much time passes from the time the substance begins to melt until it finished melting? Now you can see the graph, how much time it takes, how much substance melts, how much, give me a minute. Okay, substance melt. Note the time. The substance starts melting at minute 4 and it's completely get melted at 70 at 7 minutes. At 7 minutes. Then what will be the time? 7 minutes 4 will be 3. It will take only 3 minutes to substance to melt. It will take only 3 minutes to melt. Now we will see another question. How much time passes from until it has finished boiling? Now it is asking about boiling. You can see the substance starts boiling. The substance starts boiling at this point. It means that at 13 minutes it starts boiling and it's completely boiled at 20 minutes. 20 minus 13, it means it takes 7 minutes to complete. It takes 7 minutes to complete. I hope so you are complete this will help you to answer your question. Why would a heating curve for carbon substance will be heating curve down above? This is a question. Why would a heating curve for carbon dioxide will be different than curve Sure. What is the reason? The reason, carbon dioxide is a gas at room temperature. Carbon dioxide cannot be solid. Carbon dioxide has no state changes. Carbon dioxide sublimes. This option is also wrong. This option is wrong. This option is wrong. Carbon dioxide is a gas at room temperature. Therefore, the curve will be different. Because why we then what curve will be used for carbon dioxide? It will be a cooling curve. Heating curve is for gases. Sorry, heating curve is for heating curve is for solids, while cooling curve is for liquids. Oh, sorry, gases. Gases. I hope this is clear now. I want to indicate another point. This will help you to answer the question easily. Just 1 minute and the lecture will be over. This, what is this? Flat curve. This flat curve. It means that flat curves will indicate melting and boiling. So guys, your lecture is over. We will continue this chapter states of matter into our next lecture. Kindly subscribe our channel and press the bell icon so that you can get notification of every video on time. So stay blessed, be happy. I am found in the answer to stop share and stop recording. I will the last thing I missed that I will also provide the link of this PDF, this lecture which I delivered here. If you want to download, you can go in the subscription. You can also download the lecture. You can also follow us on Instagram, Twitter, and LinkedIn. You can also text us on WhatsApp in case of any queries, in case of uh, getting live session, getting more practice, more quizzes, more questions, more practice, and more grades. Best of luck.